This is part 2 of my video series about the notes from section 6.3, particularly about inelastic collisions. And we investigated the formula that we get from inelastic collisions. And I'll just remind you that in an inelastic collision, two objects moving with their own speeds, having their own masses, they collide and they stick together. And so they become one object. And that one object is the sum of the two masses, and it has just a final velocity, a single final velocity. And so this first problem on the back, it says that a 1,500 kilogram car is traveling west at 23 meters per second, and it collides with a 32 kilogram truck that is traveling east, but just at 5 meters per second. And the car and truck stick together after the collision. What's the final velocity of the two vehicles? So I've got a car with a mass of 1,500 kilograms, and I've got a truck with a mass of 3,200 kilograms. And the initial speed of the car is equal to 23 meters per second. And I'm going to put a note here that west is positive. So that means that if the truck is moving east, then its speed, v of truck initial, is negative 5. And I'm going to add a significant digit here, which I should have done when I wrote this problem, 5.0. Just to have a couple of digits in our solution. So, but most importantly, that negative sign is an important thing to acknowledge. So that's these two velocities are in opposite directions. And the formula, of course, is just going to be, and I'm going to use my subscripts that I just invented here, the mass of the car times the velocity of the car initially, plus the mass of the truck times the velocity of the truck initially, is equal to the sum of the mass of the car plus the mass of the truck. Remember, the car and truck stick together after the collision, and we're going to get some final velocity of that stuck together object. And I'll add that here too. The final velocity is what we're looking for. So the solution, the first thing I'm going to do is I'm going to take this equation and I'm going to solve it for v sub f. I'm just going to divide this mass sum to the other side. mc vci plus mt vti divided by mc plus mt. And when I substitute everything in, and again, being careful with the signs, I've got 1,500 kilograms times 23 meters per second plus the mass of the truck, 3,200 kilograms times a negative 5.0 meters per second. And then I'm dividing that whole thing by the sum of these two objects, 1,500 kilograms plus 3,200 kilograms. And it's worth showing you on my calculator here how I actually do this, because I want to do the entire calculation all at once. And so I'm going to start with an open parentheses so that I can write in my entire numerator, 1,500 times 23 plus 3,200 times a negative 5, and I close my parentheses. And then I'm going to divide that by the sum. So I need to open my parentheses again, 1,500 plus 3,200, close the parentheses. And then that's my solution right there. Notice, it's positive. I'm going to round to 2 digits, so I'm going to say 3.9. And so v sub f equals 3.9 meters per second. And again, it kind of makes sense that the car is moving quite fast, like 4 times faster than the truck. or more. And it has about half the mass. So you would expect that the car has a lot more, or the total momentum in this system is ultimately moving west in the positive direction. And so even though the truck is slowing the car down, the combination of these two objects is still moving west. And so I interpret my sign, the positive value that I got from my calculation, in the context of this problem. And so maybe I'll note that in the reflection here that we should interpret the sign of a vector based on the context of the problem. And that's pretty much it. This is a pretty straightforward example of how to use a perfectly elastic collision with this formula. Now, I'm not going to solve this problem here. I'll just leave that for you. But it is interesting to note that this is actually how we measure the speed of the pendulum. Or I'm sorry, the speed of a projectile like a bullet. We shoot it at this hanging mass that's at rest. And then, of course, because the bullet gets embedded in the mass, this is a perfectly inelastic collision. So we can use our formula for that. And then the pendulum's going to swing and it's going to achieve a certain height. And it's actually from that height that we can determine the initial speed of the bullet. And so in the solution, I want you to think about a couple things. First of all, this v sub b is like the velocity of the block. And it has a certain velocity only after the collision. So really, this is our final velocity of the block and the bullet together. And you can figure that out if you do an energy conservation. You know that if it has a certain amount of kinetic energy, the whole thing together, the bullet and the block, 1/2 mv squared, then this thing is going to swing and it's going to come to rest at a certain height, mgh. So you got to do a conservation of energy to get to the velocity, the final velocity of the bullet and the block together. And then when you have that, you can use conservation of momentum for a perfectly inelastic collision to get to the velocity of the projectile. So this is a little challenging because you have to really break it into two smaller problems, but you can do it. And I'll also say that here's a list of all the additional practice that you can do from the textbook in order to work problems for this topic. Remember, the practice problems are really kind of like these problems up here, but the formative assessment problems and some of the chapter review problems get you thinking a little more conceptually about perfectly inelastic collisions, and that'll help you out on some multiple choice questions. That's usually multiple choice questions test our conceptual understanding, and the free response questions test our ability to actually use formulas to do a computation and come up with a result. And then lastly, you know what section to look for in the book, and it's just the first couple of pages of section 6.3 that are relevant to this particular set of notes. And finally, if you look at the digital copy of this document, you can follow this link to Khan Academy. It's an article, and they do a great job of explaining physics and in particular these different types of collisions, and I highly suggest you check that out.